Welcome back. Now we know that we have a static mesh called SM cone, and it has a complex geometry, that's the triangle mesh itself for the cone, and it has a simple collision, that's the collision hull, our box simplified collision. And we saw that our ball, which is simulating physics, bounces off of the complex collision when our collision complexity is set to use complex collision as simple. But when we use simple collision as complex, well, we use the simple collision. It's bouncing off of the box simplified collision. And we saw that if we set this to simple and complex, we get the same result. We're using the simple collision. So what's the deal with simple and complex? Where's the and complex part? Well, we can optionally use the complex collision when we use queries. The word query literally means question. And in game development, when we perform a query, that's exactly what we're doing. We're asking a question. Would we be hitting something if we were to shoot an invisible line out into space, or perhaps sweep an invisible shape across space, and see if we hit something? We can easily perform a query. One of the most simple types of queries is a line trace. We're going to try out a line trace now. Let's go into our Blueprints folder, into Query Actors, and let's find our BP line trace actor and open that up. Now, this is a very simple actor. If we open our viewport, we can see that it has one simple little static mesh, a static mesh sphere. And if we go to our event graph, we'll see that it only has one little bit of logic here. On begin play, we're calling this function called line trace by channel. Line trace is a query. It shoots out an invisible ray into space, sees if that ray would hit some piece of geometry, and then returns a result in the form of a structure called a hit result. Now, we've seen hit results before. If we drag out and break the hit result, we'll see that we can expand this node and get all kinds of information pertaining to a hit. We saw this with our hit callbacks. Line traces also can get a hit result. Now, a line trace traces against a trace channel, one of our collision channels. Specifically, it uses the visibility channel, and any object in the world whose collision settings are set so that it has a block response to the visibility channel, those objects that block the visibility channel will be hit by this line trace. Now, the trace has a start and an end location. We're passing in the result from getActor location for the start, and for the end, we're getting the actor location and adding a vector to it. What are we adding? We're adding the forward vector scaled by 200 units. And basic vector math tells us that once we take that forward vector scaled by 200 and add it to the actor location, we will get the location that is 200 units outward in the forward direction from this line trace actor. Now, line traces have the ability to be drawn as a debug shape. We'll actually get a debug line and a debug point at the hit location if we have a hit. And if we expand the dropdown, we can see that the draw time for this debug shape is 60 seconds. That's because I changed it to 60 for this project. You can change it to whatever value you want. So our line trace actor is going to shoot out a line and see if we hit something. And our static mesh SM cone is set to block the visibility channel, and its collision settings are configured such that it should be hit by this line trace. So we're going to drag out one of these line trace actors. We're going to drag one straight out into the world and bring it up a little bit. And I want to click on this icon that lets me cycle into local space so that I can see this actor's local forward direction. I see it's pointed this way. I want to rotate it by 90 degrees so that it's now facing the cone. And I'm going to move it a little bit closer so that it's going to hit the cone when it performs the line trace. So on begin play, I expect to see that line trace. Let's press play. And there we go. We see that our line has extended out into space by 200 units. We can see that the line turns green at this point where we have a red square, that's a debug point being drawn. And that's because we have a hit there. That's indicating a hit. And if I hit tilde and show collision, I can see that that hit is at the surface of the simplified collision because our line trace is tracing and trying to hit that simple collision. We don't have any hits on the complex geometry for our cone. And that's because collision complexity is set to simple and complex. Now, what's this and complex part? Well, if this mesh is set to simple and complex, well, then our line traces can choose to trace against complex collision if we want. Line trace by channel has the option trace complex. It's a Boolean, and we can pass in true there if we want to trace against complex geometry. If I check this checkbox, well, now we're passing in true, and our line trace is now tracing complex collision. Let's see what happens if we press play. Well, look at this. We're bypassing that simple geometry, and we're tracing against the triangle mesh. We're getting a hit on one of those polygons, one of those triangles. This is much more accurate and much more expensive. So tracing complex is something that you rarely will do in a serious game project because it's more complex. But if you need complex, you can get complex. Notice the ball is still bouncing off of the simple collision, and the query, the line trace, is hitting the complex collision. We're using both. That's the and part in simple and complex for collision complexity. This is the most versatile. It allows us to have the option to trace against complex collision if we so choose. If we pass true into trace complex. If we pass false in, we're just going to trace simple collision. And any geometry that we hit, we'll only hit its simple collision. And if we don't have simple collision on that geometry, we will not register a hit. Okay, so now we understand collision complexity. At least use complex collision as simple. We know what that does. Use simple collision as complex. We know what that does. And now we know that simple and complex can use both. Our physics objects will bounce off of the simple, and our queries will hit the simple or the complex, depending on whether we're tracing complex or not. Now that just leaves one last setting that we don't know about, and that's project default. Well, if we set this to project default, then it's going to default to the project default setting for collision complexity. And we can go to Edit and select Project Settings to see what that is. To see what that is, we have to search for Default Shape Complexity. This property here is our collision complexity setting for the project as a whole. It's the project default for collision complexity. Any static mesh asset that has its collision complexity set to project default will get the setting set here for default shape complexity. And as you can see, by default, this is set to simple and complex, the most versatile setting. And we've seen the behavior that we'll get when set to simple and complex. So if your static mesh has its collision complexity set to project default, then it's set to the setting here for default shape complexity in project settings, which by default is simple and complex. Now, it doesn't have to be. You can change it here. If you want to change it to use simple collision as complex, then you'll always get simple, no matter what you're trying to do. If you're trying to trace against complex collision with a line trace, but your static mesh is set to project default, and project default is use simple collision as complex, it doesn't matter if you're trying to trace against complex collision. You're still only going to get the simple collision, and that's going to always be more performant and take less calculations. So if you wanted, you can set this default shape complexity to use simple collision as complex, but simple and complex is the most versatile because you can choose to trace complex if you want to. And of course, you can always override collision complexity on an individual static mesh asset by setting it to whatever you want right here. Just because project settings has a given setting for default shape complexity here doesn't mean that you can't change it in the static mesh. It's only if your static mesh is set to project default that it will actually use that default shape complexity in project settings. If you change it here, it's going to use whatever setting you set it to here. So now we know about collision complexity. And one last thing that I'm going to point out before we wrap up is I want you to remember that when we created this cone in modeling mode, by default, it did not have a simple collision. And when we opened it up in the static mesh editor, we saw that it was set to use complex collision as simple by default. So it's important to know that if you create a new mesh in modeling mode, it's going to be set to use complex collision as simple. It's going to be that setting by default. So it's a good idea to go ahead and add a simple collision, a collision hull, and change this to, say, simple and complex, or use simple collision as complex, one of those, because you rarely want to use complex collision as simple. That's something that will affect the performance of your game, so you really don't want that. Now, obviously, you're not going to have a box collision volume for something that looks like a cone. That's not something that you would typically want. So we just use that for demonstration purposes, but I can remove this box by going to collision. I can click on remove collision, and I'll remove it completely, and we can add a different type of collision. Now, these 10 DOP X, Y, and Z are different types of collision that are appropriate for specific types of shapes. If I use 10 DOP X, you'll see that it looks like a box, but it's tapered in one direction. If we take a look at our X direction, it's tapered in that X direction. And that also doesn't look great for a cone. So I'm going to go ahead and remove that collision. I can use the top collision option or this collision option. We get the same thing. I'm going to remove collision and show you 10 DOP Y. And this is the same thing. It's tapered in the Y direction. I can remove that collision and show you 10 DOP Z. And we can see that that's tapered in the Z direction, which is a little better. It's kind of good for a cylinder, but not quite for a cone. So it's better, but not that great. And of course, a capsule and a sphere and a box are also not great. So what do we do for a shape like a cone? Well, at the bottom right, we have a convex decomposition. This allows us to make a little bit more customizable collision hull. And if you don't see convex decomposition, just go to Window and check the checkbox for convex decomposition. You can configure this with a hull count and a max hull number of vertices, as well as a hull precision. And if you click on Apply with the default settings, you get a pretty good collision volume. In fact, this is pretty close to the original mesh here. You could even make it more optimized, a less number of polygons, by changing the max hull verts. If I change it to 8, for example, and apply, well, we get less vertices, and it's a little bit more performant. It's a little hard to see because it's at the same location as that mesh, but it's a little bit better. It's a little bit less polygons. So that's a way to create some collision geometry as well. And of course, we can go in and test this out and see that now we're using our simple geometry. We can verify that by going into our details panel. We see that we're using simple and complex. And if I look at my line trace, I can uncheck trace complex and trace against simple only. And we can test this out. And we can see that we got a hit. And it's much more accurate to our mesh. It looks a lot better than when we were tracing against that box, because the box was just not accurate to the cone's geometry. Now, it may look like I didn't get a hit here, but if we zoom out, we can kind of see that debug point. It's a little harder because our mesh is sort of occluding that hit. It's hard to see, and that can happen if your collision hull is occluded or covered by the real geometry. That can be a little bit harder to see. We can prove that it's there, though, by using a debug sphere. If we draw a debug sphere, after we get our line trace right here, and for the center of the sphere, we can use the impact point. We've done this before, and set our radius to, let's say, 8, and our duration to 60 seconds. Now we can test this again, and we can see that we did get a hit. It's just a little bit inside of that geometry. And that's because we used a less accurate collision hull. We may indeed want to use 16 for our max hull verts. We can go ahead and apply that. We can see that it's a lot closer to the true geometry. And if we play test it, we'll see that we get a little bit better of a result there. It's up to you and the needs of your game how close to the true geometry you want that collision hull to be. But in general, we rarely use the triangle mesh. We almost always use a collision hull when we detect collisions. So now we understand the collision complexity setting on our static meshes. And the very, very last thing I'm going to point out is if we were to go back to collision complexity and set this to use complex collision as simple, as soon as we do that, now that we're using the complex collision, the triangle mesh, we can't let this object simulate physics anymore. It has to be static. If we lift it up and we go to its static mesh component and we check simulate physics for it, and we have it gravity enabled and we press play, well, it's not going to fall like you expect. And if we stop, we get a warning that says trying to simulate physics on this actor's static mesh component, but it has complex as simple collision. That is not compatible with trying to simulate physics. It has to be static if you're going to use complex collision as simple. You can't use complex as simple if you want to move it. But if I set it back to, let's say, simple and complex and press play, well, now we'll see that it falls and it's able to simulate physics. So that's something to keep in mind. You can't simulate physics if your geometry is using complex as simple. I'm going to go ahead and uncheck simulate physics there. And now we have our mesh and we're using our new collision hull that we used with convex decomposition. All right, so now that we understand collision complexity, we can continue with our analysis of Unreal Engine's collision framework. I'll see you soon.